Hi friends, welcome to Easy to Learn channel. In this video, I am going to explain about orthogonal signal space. Any vector can be expressed as a sum of its components along n mutually orthogonal vectors they are provided. So these vectors form a complete set of coordinate system. So if you take similarly, it is possible to express any function f of t as a sum of its components along with the set of mutually orthogonal functions if these functions form a complete set. So let us see the approximation of a function by a set of mutually orthogonal function. So if you approximate that function based on the set of mutually orthogonal functions. So how to do that one? Now consider a set of n functions. So n function here, the n functions are g1 of t, g2 of t up to gn of t, which are orthogonal to one another over an interval t1 to t2. So here these functions, n functions are orthogonal. That is nothing but if it is orthogonal means what? Here if you prove that if it is orthogonal means gj of t and gk of t dt is equal to 0 when k is not equal to 0. When it is orthogonal, these two functions are orthogonal when k is not equal to j. Right? When j and k are equal, k is equal to j. That means we are getting what we are getting? Gj square of t into dt. That is equal to kj. Now consider an arbitrary function here. Now if you consider an arbitrary function f of t be approximated over an interval t1 to t2 by a combination of these n mutually orthogonal functions. So now I am considering one function f of t with an interval t1 to t2. So that function which is a combination of n mutually orthogonal functions. So mutually orthogonal functions are nothing but what? One is component value and the other one is function. F of t is equal to c1 g1 of t plus c2 g2 of t and so on, cr gr of t and so on, gn cn gn of t. So I am taking f of t is equal to, so this complete series I put here as summation r is equal to 1 to n cr gr of t. Now we must choose c1 c2 and so on cn such that the mean square of fe of t is minimized. Based on these component values, the error function is minimized. How to write that one? F of t is equal to summation r is equal to 1 to n cr gr of t plus fe of t. Now fe of t is equal to what? F of t minus summation r is equal to 1 to n cr gr of t. Now if you find out the error function e is equal to 1 by t2 minus t1 fe square of t into dt. What is fe square of t? Here this is the value. So you have to substitute this value here. Right? So e is a function of c1, c2 and so on cn, and if you minimize that error, the component, that means differentiate e with respect to c1 is equal to differentiate e with respect to c2 and so on, differentiate e with respect to cn is equal to 0. Now I am considering the equation differentiate e with respect to dcj is equal to 0. Now what is e here? E is nothing but what? This value. You have to substitute this value in place of e. Now I am substituting in place of e this equation is equal to 0. Now all the terms that do not contain cj are 0. So based on the differentiation, if there is no cj in that above, if any equation means that value is 0. Now so we have to check differentiation. So it is in the form of a minus b whole square. Now again you have to write a square minus b square, a square plus b square minus 2ab. Now a square. A square is nothing but f square of t into dt is equal to 0. You have to differentiate this one. Here there is no cj term, right? So this value is 0. Now next one. Differentiation of cj. Next cj square dj square of t into dt is equal to. Now second term is this one. So if you differentiate different parts, this one is f square of t, a square plus b square minus 2ab. So now only two terms are here. These two terms are not equal to 0. Sorry, it's only one term, that is f square of t into dt is equal to 0. So this equation, this is 0. Remaining parts we can get if you differentiate cj. So that is second minus 2ab. So minus 2ab is nothing but minus 2 cj gj of t into f of t. So that is minus 2 cj gj of t into f of t plus cj square gj square of t into dt, which is equal to 0. Now in this equation, in this differentiation and integration getting cancelled, we can get this value, that is minus 2 cj gj of t into f of t plus cj square gj square of t into dt is equal to 0. So if you differentiate this term, we can get differentiation of this term is minus 2 cj gj of t into f of t. If you differentiate this equation, we can get 2 cj gj square of t into dt. Now you have to send this equation to other side, that is 2 into integral t1 to t2 f of t gj of t into dt into cj is equal to 2 cj integration of, sorry, here there is no cj, right? Because differentiation of cj with respect to cj is 1. 2 cj integration of t1 to t2 gj square of t into dt. Now from this equation, if you find out cj value, this is cj value, right? So if you find out that cj value, cj is equal to what is the equation? This equation. Here 2 getting cancelled. So we can get integration t1 to t2 f of t gj of t into dt divided by gj square of t into dt. So for simplification, this equation I am taking it as kg. So that is kg. That means this value is kj, that is 1 by kj integral of f of t gj of t into dt. So if you minimize the mean of the square error, we must choose the component value. Based on the component value, the error is minimized. Thank you.